My second question, my second video is on thin lens formula. But as I said, the lens maker, they will not they say directly derive lens maker formula. They can be say that derive focal length by using refractive index and radius of curvature. Similarly, in thin lens also, bachon, they can be asked this way, that by stating assumptions, because here the assumptions is little changed. Because now earlier it was a single surfaces that we are doing, but now the assumptions, because it become a lens. It become a lens, it is a thin lens. Since the lens is thin, there is a concept of optical center. So my dear, because of the concept of optical center, so that we can measure the distance from its surface. When the lens is thin, we can measure the distance from the surface, that is nothing but from the optical center. And for this reason, they have made this name of this question as thin lens formula. So very first assumption is that the lens taken should be thin. So that when I measure the distance from its surface, it doesn't make any affection, it doesn't make any problem. If the lens is thin, we can measure the distance from the surface, that is nothing but from optical center. So here by stating assumption, derive relation between object distance u, image distance v and focal length f for real image of an object using convex lens. So in the question, there can be a question, derive the same formula by using convex lens for virtual image. So at the end, again I will give you the diagram. You have to derive yourself by looking this topic. And I will give you the diagram for concave also. In concave, there is only one image, that is virtual image. There is no real image in concave. So there is not a problem for concave, but I will give you at the end both the diagram, that is convex lens forming virtual image, and you have to derive the same formula. And by using the concave lens, which is also forming a virtual image, you have to derive the same formula. But I am showing you the video lectures by using convex lens, and the image is real image. So first I will state the assumptions here, so that it will be clear that what are the assumptions difference between the lens maker assumption and this assumption. The very first assumption, the lens should be thin. The very first assumption, the lens should be thin. Now my dear, anybody will ask you why the lens should be thin, so that the distance should be measured from its surface, from the surface of the lens, that is optical center. Agar lens broad hoga, to distance measure karna it's difficult, because we have to measure the distance from the surface. Now there is no pole, so we are measuring the distance from the optical center, that is on its surface. It is possible when it will be thin, you can easily measure the distance. Okay. The second is the aperture of the lens. This you know, the aperture of lens, mirror, everywhere it is the same. The aperture of lens should be small. This is because to remove the aberrations, to remove the defects. Okay. Third, my dear, you all know this also. The incident ray, refracted ray, the incident ray, refracted ray makes very small angle with the principal axis. So I hope these assumptions we know from previously only, that the aperture of lens should be small, and the incident ray, refracted ray, so sir, makes a very small angle. That you remember alpha, beta, gamma earlier used to take for the curved surface. They are making an angle, if you remember. So the incident ray, refracted ray makes very small angle with the principal axis. And fourth assumption is again new for this topic. The object should be a small object. The object should be a small object. It is not a point object. Take care, my dear. In lens maker, the object was a point object. But for thin lens, the two assumptions are different. You can see the first and the fourth. The first was the lens should be thin, where in the lens maker we have not have such assumptions. But in the here, when I'll go for a thin lens formula, the assumption number 1 is the lens should be thin, because as I said, we have to measure the distance from its surface, that is optical center. And fourth one, the object which you will be considering, that object is not a point object in the question. The object is a small object. And that small object is nothing but a line object. You must be knowing the line object we have taken in the case of mirror, if you remember. So the object should be a small object. This is the assumption. Now let us draw the diagram. So I have taken this, and this is my optic axis, my dear. This is the optic axis and this is the lens. Say this is the optical center. This lens is thin, so it can be measured easily the distance from its surface. This is called optical center. Here I have taken the object. This is the object, my dear, that is a small object, nothing but a line object, and I have taken this as AB. You can see. And now here the ray is traveling parallel to the principal axis. This is your incident ray. No doubt, my dear, after refraction, as soon as it will fall here, after refraction, it will be passed through the focus, and one ray will pass through the optical center also, like this. Say this is your focus, my dear, because the ray parallel to principal axis, of course, it will pass through focus, and the ray which pass through optical center from class 10th, you know, it will pass straight, and here the image is obtained, my dear. Here the image is obtained, you can see. Here the image is obtained in this case, and the image is nothing but B dash A dash. You can see the image is obtained as B dash A dash. Now here, can we mark? Suppose here I am making a word M. Here is M. Right? Here is your object distance minus U. Here is your image distance plus V. You know why plus V? Because this is in the direction of incident ray, and this is minus because it is opposite to the incident ray. And here, my dear, you can mark from optical center to principal focus. You can mark, because for convex lens the focal length is always positive. So here it is plus F. So I hope the diagram is clear. Now here, my dear, can we take the two triangle? The triangle. Let's start for the proof. Triangle ABO and triangle A dash B dash O are similar triangle. Triangle ABO and A dash B dash O are similar triangle. Now, my dear, assume that the height of this, I will do it at the end. Let the height of this object is HO, and let the height of the image or size of the image is HI. No doubt it is inverted. While substituting, I will put this as minus. But right now I have written just HI. Okay, because it is inverted, so I will put it as minus. Whereas object is always vertically upward, it will always in plus. So now in this two triangle, don't you think? Always I told you that take the image ka side first and then object side. So therefore this is A dash B dash upon AB is equal to B dash O upon BO. You can see. And my dear, B dash O, from the figure you can see B dash O is your V, whereas BO is minus U. Put this as equation number 1. I hope this is clear. Now my dear, the second step, can you see, this is over. This is the over with the first triangle. Now there is one more triangle. Also, triangle, you can see triangle. My dear, can you see the triangle that is MOF? Please look at the triangle. MOF and A dash B dash F. So triangle A dash B dash F and MOF are similar triangle. MOF, you can see, and A dash B dash F are similar triangle. Again, therefore, taking image side first, A dash B dash upon A dash B dash, this one, upon MO. You can see MO. So this is MO is equal to, now here my dear, you can write B dash F upon OF. And we all know that, my dear, B dash F is unknown to us. From figure you can calculate B dash F. You all can see B dash F is nothing but B dash O minus OF upon OF is known to us. OF is value is plus F. But my dear, B dash F was unknown. No value was given for B dash F. So how I found B dash F? Sir, B dash F is taken OFB. In OFB, in this line OFB dash, sir, OF plus FB dash, OF plus FB dash is equal to OB dash. OF plus FB dash is equal to OB dash. So FB dash is equal to what? OB dash minus OF divided by OF. Here I am writing from figure in OFB dash. OFB dash, you can see the figure and you can calculate B dash F ka value. B dash F is nothing but B dash O, that is from O to B dash minus OF will give me FB dash. So here therefore this will be A dash B dash upon MO is equal to B dash O. You can see B dash O is your V minus OF is F divided by F. Am I clear? But since MO is equal to AB from figure, your this MO is equal to AB. So nice. MO is your AB. So my dear, here I can write A dash B dash upon AB is equal to V minus F upon F. This I will put it as equation number 2. So now equation number 1 is A dash B dash upon AB is V upon minus U, and equation 2 is A dash B dash upon AB is V minus F upon F after solving. So now I can say left hand side of equation 1 and left hand side of equation 2 are same. So here I will order equating equation 1 and 2. We get V upon minus U is equal to V minus F upon F. So on cross multiplying, I will get, therefore, Vf is equal to, when I will cross multiply this, I will get minus UV minus UV plus minus and minus become plus UF. You can see. Put this as equation number 3. Now my dear, here I will say by dividing equation 3 with UVF. So when I divide equation 3 with UVF, we get VF upon UVF. In mirror formula we used to divide by UVR. Now it is UVF is equal to minus UV upon UVF plus UF upon UVF. So here I hope you are understanding what you are getting. VF cancel, UV and UV will cancel, UF and UF will cancel. So here the answer will be, therefore, this is 1 upon U is equal to minus 1 upon F plus this is 1 upon V. You can see, this can be written as, my dear, I have taken 1 upon F on this side, therefore this is 1 upon F is equal to 1 upon V minus 1 upon U. So this is your thin lens formula, my dear, which I obtained. This is your thin lens formula, my dear, which I obtained by using a convex lens for a real image. Remember, my dear, this year, in year 1920, there is already in exam the lens maker formula is being asked in all set 1, set 2 and set 3. Everywhere there was a lens maker formula. Now in the next year we are expecting a formula based on thin lens. So please prepare yourself very well. Now after this I will give you the diagram for convex lens forming virtual image, and same method you please derive in your book by looking the same thing, how to go for convex lens virtual image. The formula must be same. Even by using concave lens for virtual image, the formula must be same. This two topic you please derive in your book and please send it on my WhatsApp or on my email. Thank you, Bacha. Now my dear, let us the same question, thin lens formula, but if they will ask you that derive this formula for virtual image and using convex lens. So you have to take one small logic, my dear. From class 10th you all know that convex lens forms virtual image when the object is placed between focus and optical center. Between focus and optical center. So use that common sense, and here look at this diagram. So here I have drawn the convex lens. Here it is the optic axis. Say here it is the optical center, and here is the principal axis. Now my dear, suppose here I have taken focus of this convex lens, right? And the object, as I said, it should be between focus and optical center. So now my dear, suppose I have drawn here the object. Name of the object is no doubt AB, but it is placed between focus and optical center. So the ray will pass parallel to the principal axis, that is like this. And my dear, it will converge at this point, you all can see. Let another ray is passing through the optical center like this. My dear, this ray, this which is going here at the focus here. So instead of marking focus here, because there will be two focus, one for this surface, other for this surface, but it is converging, so it will be go here, and say it is forming here, my dear. The another is going this way. So here you can see the image, and this is the virtual image, my dear. Why this is the virtual image, you know all, because it is on the same side of the object. So this is the virtual image you can see, and the name of this is, here I will put B dash and here I will put A dash. So this is the virtual image I obtained, my dear. Magnified virtual image you can see here. Okay, now as far as the distance part is concerned, and again you can mark this point as M according to my previous case. You can draw this line properly so that it become a triangle MOF, 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 and A dash, B dash, O. MOF and A dash, B dash, O. So that you can see from previous topic, you can derive it smartly, my dear. Here it is minus V, that is image. Here it is optical center, my dear, right? So here it is minus U, and since the focal length of the convex lens is always positive, so here you can take is as plus F. So this is the diagram, my dear, where the convex lens forming virtual image. So please, in your notebook, you please solve this, the same formula, thin lens formula. By this also, you have to prove 1 by V minus 1 by U is equal to 1 by F. So use the same concept as what I have done earlier and derive this also with the same method. And let me know, write it in your book, and please WhatsApp at my WhatsApp number pe the entire derivation, as well as you can put it on my email also. Now similarly, my dear, we can show the diagram for lens maker formula for concave lens. So this is for convex lens. Now here I am writing diagram for concave lens forming virtual image. So this is your second question. This was your question number 2. Earlier it was, this is your question number 3, and which I have derived earlier is the question number 1. So there are, in all there can be a 3 question. So science can be asked any of the question, my dear, get ready for it. So here now let us draw the diagram for concave lens. This is your optic axis, as I told you, this is optic axis, optic. Here is the say optical center, and this is your principal axis. Now, so what is the diagram, my dear, for this case? Now for this case, say here is the object. Here is the object. Name of the object again AB. The ray will pass parallel to the principal axis. And since concave is a diverging lens, concave is a diverging lens, my dear. So here it will diverge here. And this will become at the back. And it will pass through the principal focus. Similarly, my dear, another ray from this will pass through the optical center like this. You can see this way. Here you can see the image, my dear. Here it is the virtual image formed by the lens, by the concave lens. Here I will write A dash and here I will write B dash. So this is a diagram by concave lens, and here, my dear, I can draw this point. I can write M. At this point I can write M, so that you will get my topic of deriving the things. And here this is the MO. So again here MOF, MOF, MOF and A dash B dash F. MOF and A dash B dash F. And no doubt this MO is nothing but equal to AB. So everywhere the topic, the derivation is same. Only the diagram is different. That's what I requested you all, that please for every diagram you derive the thin lens formula, so that you will have a practice also. So now here let us mark the distance. So from here to here, the optical center, it is minus U. From focus to this, it is minus F, because concave lens focal length is negative, and here from O to your image it is minus V. So this is all, my dear. The three diagrams I have done, one derivations by real image for convex lens. Now I have left it out to you all to derive the thin lens formula. Here also you have to prove the same formula, that is 1 upon V minus 1 upon U is equal to 1 upon F. So these are the two homework I am giving to you all, so that you will have a practice of deriving thin lens formula, which is important with the exam point of view. This is for convex with virtual image, and this is for concave with virtual image, and which I have solved is for convex with real image. Because in the exam, there can be a chance that they put a proper condition that for this particular question, you derive the thin lens formula. So this is all the three diagrams. Now let's go for linear magnification concept. I repeat, the linear magnification concept for lenses.